Today on Flipping Science, we're looking at how to make a metal from an ore. So you need to be able to predict whether a metal is likely to occur in nature uncombined or combined with other elements, given its position in a table of reactivities. And identify the stages in the production of a metal from its ore and explain why not all the steps might be necessary. So metals are usually fairly reactive and they oxidize when they react. So here we have a metal, it's going to metal ions and it's producing a certain number of electrons. The more easily it does this, the more reactive the metal is. And conversely, the more easily it does this, so produces electrons, the more difficult it is to reduce the ions of the metal. So going back the other way can be quite problematic if it's a very reactive metal. And we can rank our metals in order of reactivity in terms of how they react and how easy they are to oxidize or reduce their ions. So here's some activity series. So at the top here we've got lithium, down the bottom we have gold. It's saying here lithium and potassium, barium, so on, they never occur in their free state. That means you'd never just dig up a pile of sodium, for example. It's already reacted with something else in the environment. Some metals in the middle here you can find free in nature every now and then. Then others that are even less reactive, you find them readily in nature. So gold, silver and platinum, for example, because they're not very reactive, they don't react with any other elements in nature to form compounds. If we look at how they react, you can dunk these in acids and they'll release hydrogen, so the ones at the top of the activity series. The ones down the bottom, they don't react with acids readily and don't produce hydrogen. So most metals that you find in the environment are found as minerals. That means they're combined with other elements. Some, however, you find them as their mineral because they don't react very readily. So if we look at gold, silver and platinum, for example, the ores that they come from are gold, silver and platinum ore. They don't have a particular name necessarily because they're not reacting with anything in the environment. So you usually just dig it up, combine with quartz and other things in the environment, then you separate out the quartz from the precious metal, and that's how you find it. As we go up the activity series, we start looking at lead, zinc, iron and copper. We can see that we're starting to get different names here, and that's because we're combining with different elements. In the case of galena, sphalerite and pyrite, we're combining with sulfur. So these ores, galena, sphalerite and so on, that's where we get our lead and zinc and so on. We have to extract the lead and zinc from the ore to have the useful metal. So if we look at the table on the previous slide and the reactivity series, you can see that the more reactive a metal is, the more likely it is to be found in a combined state in the Earth's crust. And what I mean by that, it's more likely to have reacted with something in the environment. So highly or even moderately reactive metals can be found combined with other elements such as oxygen and sulfur. So down here, this is a picture of galena. So this is where we get our lead from. So it's lead sulfide with other bits and pieces. So it's combined with sulfur in the environment. The less reactive metals don't react with the other elements because they don't easily oxidize. And if they don't easily oxidize, they don't produce ions. And if they don't produce ions, they're not going to stick with other things in the environment. So down here we have gold on a quartz substrate. So the gold itself, it's not reacting with anything. It's just stuck as part of that rock there. So now we'll go through the steps required to extract a metal from its ore. Some metals will use all of these steps, others not, and we'll talk about some of those later on. So the first step is to concentrate the mineral. In this step you're getting rid of the gangue, which is the silicates that are associated with the mineral. So by removing the silicates you increase the concentration of the compound that contains the metal ion for reduction. So in zinc, for example, they use a froth flotation process to do this, and we'll talk about this in another video that I'll link to down the bottom. So the next step is to convert a mineral into substance that can be suitable for reduction. And this might be because the compound you convert it into is much more easily reacted with. So a good example is you might roast metal sulfides in air to produce oxides, and oxides are they can get reduced at much lower temperatures. So that might be why that happens. So this happens in lead and zinc production. And again, we're going to look at this as an example in zinc production. You then need to reduce the metal compounds in the metal, and by that I mean the metal ions in the metal need to be reduced to the metal. This can be done using chemicals. For example, carbon monoxide is used in iron production. Or you can do it using electrolysis, such as in copper or aluminium refining. Last step is refining. This will get rid of any trace impurities that are left over from the reduction of the iron stage. A good example of this is when you're converting iron to steel. So iron, as it comes out of a blast furnace, has a really high carbon concentration. To turn it into steel, you get rid of that carbon by blasting the iron with oxygen in what's called the basic oxygen steel process. That oxygen reacts with the carbon that's in the molten iron and gets rid of some of that, and that's how you produce steel. So different metals have different steps in the refining process. Some metals require more processing than others. So let's look at some examples. So iron ore in Australia has a very high iron concentration, so they don't bother with the concentration step. They don't do froth flotation, for example. They just go straight into the reduction step. So here's hematite down here. This is one of the more common iron ores that's produced in Australia. Here's a picture of my friends at Iron Knob, which was one of the first places where they did this in Australia. So because it's higher iron content, you don't have to worry about doing a concentration step. Aluminium and zinc, they're produced through electrolysis, and because they're produced through electrolysis, when they come out at the other end, they're usually very high purity, so they might be 99.99% pure. So here's an ingot of aluminium, I think, down here. You wouldn't need to do a refining step on that, like the basic oxygen process that you do have to do with iron and steel. If we have a look at zinc, for example, though, zinc does require the froth flotation step because there's a very low zinc concentration in the ore, which is usually sphalerite. So today on Flipping Science, we looked at how metals are found in nature and also how you can produce a metal from an ore. That's it for Flipping Science today. See ya.